Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about some practice examples on loops. In our previous classes, we have done some examples on loops and we use the concepts which we already discussed in our previous classes. Please follow our playlist from the beginning so that you will have a better understanding of the complete Python language. We use the concepts which we already discussed in our previous classes. Our assumption is you already know those logics. Based on that, we are continuing this example. As we already discussed in our previous classes, these examples will help you a lot in solving the complex programs which we discuss in our later sections. That is how this course is designed, and these examples are chosen. These are very helpful. So please take the question, try to solve it on your own, then check for the solution. Coming to our example, this is the example. We have to convert our decimal number to binary number. Let's take an example and understand how we will do that. Do the conversion decimal to binary number. The example which we considered here is 72. Decimal number 72 should be converted into binary number. What's the logic here is we have to divide it by 2. 2 36 72. The remainder value is 0. 2 18s 36, the remainder value is 0. 2 9s 18, remainder value is 0. 2 4s 8 and the remainder value is 1. Like that, 2 2s 4, remainder value is 0. 2 1s 2, remainder value is 0. And finally we are having 1. So this is the binary number 1 0 0 1 0 0 0. That is the binary number for decimal number 72. So this is the binary number 1 0 0 1 0 0. This is the binary number for decimal number 72. So the same logic we discussed in our previous classes. We are dividing our number till you get 0. So what we have done, we have taken a loop, we are dividing this number till we are getting up to 0. In our previous examples, we divided by 10. Here we are dividing it by 2. And in our previous examples, we already discussed that how to take the modulus value. Remainder value is getting by using a modulus operator. So both the logics which we discussed previously, we use that concept and we will apply this. And one more thing we have to understand here in this example, we are choosing that we are displaying our binary value in integer format. In order to get this integer format, the logic which we use here, see, initially we are taking three values. Place is equal to 1, binary is equal to 0, and the remainder value is taken in a variable named as REM. So initially the binary value is taken as 0. Why we have taken that? This binary number is shown in integer format, means this is ones place, tens place, hundreds place, thousands place, 10,000 place, 100,000 place, thousand place. In order to get that, in order to get this integer format binary number, what we are doing here is take the first remainder. So initially binary value is 0, taken as 0. Binary is equal to remainder into place plus binary number. Initially we have taken it as 0, so that's why we are placing it as 0. So this entire summation 0 into remainder into place plus binary value is again saved in binary number, means each time we are updating our binary value. That is what we are doing here. So coming to our first loop, in the first loop the remainder value is 0. 0 into what's the place? Ones place plus binary value. The output is 0. Again it's saved in binary value. In the second loop, binary is equal to remainder. What is the remainder here? 0 into tens place, means what we are doing here, the place value is each time when we go into the loop we are multiplying it by 10. 10 plus binary value 0. The next time 0, the binary is equal to 0 into next time place is hundreds place, 100 plus 0. Now you will understand why we have chosen this logic. At this position you will understand. Up to now what's the binary value is? 0. Now binary is equal to remainder into 1000 plus 0. Here the remainder value is 1. 1 into 1000. 1000 plus 0. That we got it as 1000. See here. 1 0 0 0. That's why we are updating with this equation. Remainder into place tens place, ones place, tens place, hundreds place, thousands place, so on. That is what we are doing here. Coming to next one, continue this. Next one, binary is equal to 0 into 10,000 place plus here the binary value is 1000. In our previous example, what's the binary value we got? 1000. So the output is 1000. Next, 0 into 10,000, 100,000 plus 1000, output is 1000. Next one, 1 into 1000 plus 1000 is equal to, this is the output which we got. That is what we are showing it as an output. That is how we are displaying our binary number in integer format. Is it compulsory to show it in integer format? No. For understanding, for making the things somewhat complex so that you will have a better programming experience, that's why we are converted into integer format. No need. If you want to display it individually, display the 0, display 0, display 0, display 1, like that you can continue based on the conditions. If they asked you to show in the integer format, in the placement questions or in the coding situations, whenever you got. So that's why we have chosen this example. Coming to our coding part, let's check the coding part. What we have done, we are taking the number into integer number into the variable called number, and this number is placed in a variable called x. Reminder value is initially taken as 0, place is taken as 1, binary value, initially the binary value is taken as 0 while we are going into the loop, x value greater than 0, until we have to loop. How much time we have to loop? We have to loop until x value equal to 0. If x is greater than 0 means go into the loop. Each time when we are going into the loop, what we have to find? We have to find the remainder divided modulus 2, remainder value. How we will calculate that remainder value? Remainder is equal to x mod 2. Now binary is equal to, this is the equation which we use to find the binary value, remainder into place plus binary number. Initially binary number is 0. Each time the loop, when we enter into the loop, the binary value is updating. X floor division equal to 2. Why we have used the floor division? That we discussed previously. And place is updated with 10. Place is equal to 10. 10 into 1. Next time 10 into 10, hundreds place. That is how we are getting the new place value. After coming out of the loop, we are displaying the number. Binary number is 72 is 1001300. That is what the binary value of decimal number 72. Hope you understand the logic. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.